When I was 6 years old, I was failing miserably at being a 6-year-old, I must say, because there's this official Brown Child Regulation 9044, which obviously says that as a 6-year-old, you're supposed to understand fractions. So instead of thinking 6, I was supposed to think 1 over 6. But for my 6-year-old brain, 1 over 6 was just not working. And I remember like my father was sitting down with me and he would spend an hour with me just being like, okay, 1/2 plus 1/2 equals 1. And he would write it on paper and I would write it on paper. And then like I just wouldn't understand anything. And like it was an hour of doing this. Like I felt I was disappointing him. I was wasting his time. I was like, feeling anxious myself. And even like as a 6-year-old, I think many people over the course of their lifetime can relate to this feeling, regardless of the age they've been. Like, I've seen so many students in math who just, have struggled. They have struggled at some point in their career in math. They have felt that way. Anxiety, feeling like they're wasting other people's time, feeling they can't understand, feeling that they're not good enough. This is a very common feeling. And for me, it came about with fractions, with division. So in that case, I got lucky. In that case, my father was a little bit more patient than me. He switched from showing me these like weird numbers, this weird division notation thingy, to showing me a tomato. He would get out a tomato, he would cut it in half, he would show me the two pieces, and he would say, look, half a tomato, yeah? Half plus half, put it together, what do you get? And I'm like, yeah, you get a whole tomato, I got it. All right? Like I couldn't understand fractions as a 6-year-old, but I could understand tomatoes. And this is the key point, you see, because in math, whatever concept you have, there are so many different ways of understanding it. There's so many different ways, and some of them are going to speak more to you than they would to me, you know? Maybe you understand fractions, I understand tomatoes. It's different from everyone. And when I think about this, the shame I think is like we have all these standardized worksheets in math, but like how many teachers around the world are just like slicing open tomatoes because like, they know that their students understands tomatoes. That student doesn't understand fractions. This is why I made, this entire presentation on the different ways to understand this concept of division of fractions. Because there are so many ways, and some of them even university students don't understand. And I'll show you exactly what I mean. So here, this first way of understanding fractions, understanding division, is just splitting something into smaller pieces. So like you have a whole circle, you break that one object into half, and that's how you get this fraction, 1/2. But you can also think about division with regards to multiple objects, not just one object. So for example, let's say now you had 12 circles. You decided to split them into 3 groups. Now you have 3 groups of 4. And we know that, 12 over 3, 12 divided by 3 is 4. So we have these two ways of, thinking about the reference of division. Are we referring to one object being split into smaller pieces? Or are we referring to multiple objects, that are being grouped into multiple groups? When we have the second, we can also look at, comparing the different groups. Let's say we bet on 4 horses in a race. So we have 4 ways of winning. We didn't bet on 6. So if any of those 6 horses win, then we lose. Well, we can compare the odds, what are the odds of winning versus losing? And that's how we get ratios. Now all of these are still division, This is the same concept. Whether we're comparing different groups, whether we're splitting into groups, whether we're, breaking an object up into pieces, these parts we're familiar with. But there are also some more, tricky ways of thinking about division. Ones that I'm not sure every high school student or every university student is familiar with. So we're going to have a little bit of confusion, but, you're not being tested on anything. So if you don't understand, that's fine. You can slow it down. There's no pressure on you. But we can also think about, a little bit of a different case. Now, this one's going to be a bit abstract. Before, we had like a circle and we were breaking it up into pieces. And obviously, like the pieces, there were finite pieces, Like if I have one circle, one tomato, I cut it in half, then I have two. If I cut those in half, then I have four. And like I could count, I could see the things every single time. But when we think about a number line, we can kind of infinitely divide the number line into smaller and smaller intervals. So let's say before, like the intervals are 0 to 1 to 2. Okay, that's fine. But let's say we divide each of these into 4. Well, now we could have 0 to 0.25 to 0.5 to 0.75 and then 1. And we could even divide, each of these intervals into smaller intervals. We could keep on going and going and going. This is still division, but it's not like we have countable objects anymore. It's more like we're zooming in, it's like we're zooming in to see something more precisely. And that's another way of thinking about division. It's letting us zoom in to a more precise level. When we think about zooming in, we can also think about scaling. So, if you ever had high school math, they would teach you about transformations of parabolas. If you ever divide an equation like y equals x squared, if you ever divide it into smaller pieces, let's say y equals x squared divided by 10, then you might go from having, the arch in the middle, that is the tallest, to a more dampened version that's like, got less of a curve. So we can also think about scaling based on division, making things smaller based on division, another kind of zooming in. Now here, I'm really going to start to play with your head. Let's say you have 4 loonies, right? So 4 $1 coins, that gives you a value of $4. If you wanted to get the same amount in quarters, well, you can count, you would have 16 quarters. Makes sense, 4 quarters make up one loonie, one $1 coin. So if you have 4 groups of 4, then yeah, you got four $1 coins. But why is this working? How does this relate to division? And this one's really important. This one is something that I bet even 50% of university students don't understand. If you have 4 $1 coins, it's kind of like you have 4 divided by 1, right? You have 4 things, each of them has a value of 1. Whereas if you have, all of these $0.25 coins, 25 cents coins, it's like you have 4 divided by 0.25. And now you can type both of these into a calculator. When you had 4 over 1, it would give you 4, right? So if you want to get $4, each thing is $1, then you get, then you only need, 4 of those things. But if you want to get $4, each thing is only $0.25. Now you got to get 16 of those things. But the thing that's important here is the denominator. Okay, it's the unit that we're comparing it. This is a really important principle. Division is kind of like changing the unit that you're counting in. So for most numbers, you can write any number, 16.3. What you're really saying is 16.3 divided by 1. So the unit we're counting in is ones. But we could also count in like 0.25s, right? If we count in 0.25s, then, we end up with 4 times as many. That's a very key idea. If you can understand that with this simple example, you use division to change the unit. The thing you divide by becomes the unit that you're counting in. Now, this seems like, it might seem like a little bit strange for me when, you just have a simple problem like changing coins from loonies to quarters. But how about changing a standardized mean difference into, standard deviation units? This is a key statistical formula. If you have a mean in some units, like, uh, how tall is one group of people, let's say one group of boys, and then you have a mean in another group, like, okay, how tall do we have the average height in a group of girls? Well, it's fine to compare them in centimeters or feet or inches or whatever, but like you have a lot of different units. So what scientists will do is they will use this formula, they will take away the average height in whatever unit you have, but then they will divide that by something related to a standard deviation. But remember what I said, when you're dividing things, the thing you're dividing by is kind of like the unit. So this standardized mean difference, it's in units of standard deviations. This is something that people don't understand. They're just like, oh, it's some formula. I'm just dividing by, standard deviation. It's going to make it smaller. Yes, it's going to make it smaller, but this is the key thing. You're making it in standard deviation units so that you can compare it across a lot of groups. You're going to see this all the time in statistics, you're going to see things being divided. And if you don't understand this, that division is just changing the unit, then, there's so many university students that they don't understand, like, why is this formula like this? And finally, to wrap it up with an easier note, obviously division is the opposite of multiplication. You have 4x equals 20. If you want to solve an equation, well, if you see it's being multiplied, then you can divide by the same thing and it'll undo the multiplication. So we've had all of these different ways to think about division. Is it breaking an object into smaller pieces? Is it splitting lots of objects into, multiple groups? Is it comparing different groups as ratios? Is it scaling things smaller? Is it zooming in on the number line? Is it changing the unit that we're comparing in? Or is it just undoing multiplication in algebra? And there's still more ways to think about this. This is the key idea, Some of these things might have made more sense to you than others, and that's fine. That's good. Just like I, when I was 6, couldn't understand fractions, but I could understand tomatoes, maybe for whatever thing you're confused about, that you're learning about in your big fancy, university course, maybe that also has some version of tomatoes there. And that's my challenge to everyone, find what tomatoes are for you. Find what way you can understand a concept that is easy to you, because there are multiple ways to do it. And if we can all do that, I think, we can maybe start to appreciate these things that have seemed so horrible, have had so much anxiety associated with them, have had so many feelings of not good enough. Maybe we can start to change that.